You ever stop and think about how messy and complicated the real world is, but computers see everything as super precise? Well, today, we're going to dive into a really cool technology that basically bridges that exact gap. It's a way of thinking that helps machines handle all the gray areas of life, just like we do. I mean, really think about it for a second. Is a day just hot or cold? Is a car just fast or slow? Of course not, right? It's never that simple. But for the longest time, that's exactly how we forced computers to see the world, in these rigid, absolute, black and white terms. And this right here perfectly shows the problem. Classical computing, the stuff that's in most of our devices, is built on this foundation of absolute on or off, true or false, one or zero. But that's not how we experience the world. We talk about things being a little warmer or kind of fast, and it's this huge mismatch that fuzzy computing was designed to fix. Okay, so let's first get a really clear picture of this traditional black and white world that our computers have been living in. I mean, it's incredibly powerful, don't get me wrong, but it's got some serious limitations when it tries to deal with reality. This is what's called classical or binary logic. It's the bedrock of pretty much all modern computing. Every single decision boils down to a simple yes or no. And look, that's amazing for pure math and data. But the second you ask a computer, hey, is the weather nice? It can't handle it. It needs a hard number, a strict threshold, not a vibe. So how do we get a machine to think in these crucial shades of gray? Well, the answer is this really elegant and clever solution called fuzzy logic. It's all about letting machines get comfortable with, ambiguity. And here's exactly why that's so important. This quote from our source material just nails it. The real world isn't neat and tidy. The information we have is often fuzzy. So we need a type of logic that can actually handle all that vagueness without just crashing. Okay, now this slide is awesome because it shows you exactly what we're talking about. Look at that top example. The old way, Boolean logic, asks, is Nick honest? And it can only spit out a yes or a no. It's a light switch, on or off. But fuzzy logic, it can say very honest with a value of, say, 0.85, or kinda honest at 0.4. It's not a switch anymore. It's a flexible dial. It has nuance. So here's the official definition. It was developed way back in 1965 by a guy named Lotfi. And with fuzzy logic, we're not just talking about ones and zeros anymore. We're talking about all the numbers in between. Something can be, say, 70% true or zero point 0.7. And it's this simple but profound shift that lets a machine start to mimic the way humans actually reason. So this all sounds great in theory, but how does a machine actually use this fuzzy thinking to make a decision? Well, it's not magic. It's actually a surprisingly straightforward four-step process. Let's pull back the curtain and see how it works. Take a look at this. This diagram shows the basic layout. You can think of it as the four-part brain of any fuzzy system. You've got an input, and it flows through these four stages: a fuzzifier, a rule base, an inference engine, and then finally a defuzzifier, which gives you a clear output. Let's walk through it real quick. First, fuzzification. That's just turning a hard number into a human-like concept, like warm. Then, the system checks its rule base, which is just a big list of if-then instructions. The inference engine is the real brain here. It figures out which rules apply. And finally, defuzzification translates that fuzzy decision back into a solid command the machine can actually follow. And here's a perfect example of that first step in action. Let's say a temperature sensor gives a very precise or crisp reading, exactly 30 degrees Celsius. The fuzzifier takes that number and translates it into a concept we understand, warm. And it even gives it a confidence score, a degree of 0.7. And here's the final piece of the puzzle. After it's done all its thinking, the system's fuzzy decision might be something like, set the fan to medium speed. But, of course, a motor has no idea what medium means, so the defuzzifier acts like a translator, turning that vague idea back into a precise command it can execute. Spin at 1200 RPM. It's a bridge between the human world and the machine world. Now, I know what you might be thinking. This is all very theoretical, right? But here's the wild part. This technology is totally hidden in plain sight. I can almost guarantee you've already used it today, probably without even realizing it. Seriously, think about how smoothly an automatic car shifts gears, or how a modern camera just perfectly nails the focus and exposure. Even your washing machine sensing how dirty the clothes are, or an air conditioner that keeps the room just right without constantly blasting on and off. All of that's fuzzy logic making smarter, more efficient, and honestly, more human-like decisions. But, like any piece of tech, it's not some magic wand. It's not a silver bullet. It's a very specific tool for a very specific kind of problem. So it's really important to understand where it shines and where it doesn't. So let's look at the trade-offs. On the plus side, it's pretty simple to understand, it's really robust, and it is fantastic at handling uncertainty, even with cheap sensors. But on the flip side, the results aren't always going to be perfectly exact. It can't learn and adapt on its own, like, say, a neural network. And designing all those if-then rules in the first place can be a huge headache. So if you only take one thing away from this whole explainer, let it be this. At its heart, fuzzy computing is all about giving machines the ability to reason more like a person, to make good judgments based on vague information, and to operate effectively in those messy, imprecise gray areas that make up our world. And let's bring it all home by going back to that simple air conditioner one last time. The old way, classical logic, is clunky. It's either fully on or fully off, right? But fuzzy logic, it's just more elegant. It adjusts smoothly. If it's getting kind of warm, let's turn the fan to medium. If it gets really hot, then we'll kick it up to high. It feels better, it's more efficient, and it's just plain smarter. And that really leaves us with a final question to chew on. When you think about it, from customer service bots to maybe even medical diagnostics, what other complex systems in our lives could be made better by thinking a little less black and white and a little more fuzzy?